Oh, all right. Avery, you got it?
I got 40 grams of the 15% alloy to 60 grams of 40%.
40 grams is right. Okay, 40 grams and then 60 grams. So if you got that, you're good on that. All right, now you can do a chart or you don't have to. The key thing here, percent times amount. Percent times amount to get the amount of pure gold. So you got to figure that out. Now, if you're doing a chart, let me go that route, and then it will automatically set up the equation. And so you got, I'm just going to do alloy 1, alloy 2, final alloy. And we got amount. We got percent gold. And then I guess the easiest thing here would be kind of pure gold. All right, alloy 1. We don't know how much. The only thing we know how much is the final alloy. Now, this is kind of the big step. This is probably where the most mistakes are made. So if I let the first alloy be X, I know the final alloy is 100 grams. What's alloy 2? How do I represent that? 100 minus X. Okay, they add two things add up to an amount. Okay, it's going to be 100 minus X. Now, we know the percent of alloy 1, that's 15%, 0.15. 0.40 is the second amount, and then 0.30, 30% is the final amount. Percent times amount gives you the amount of pure gold in that alloy. So it's 0.15X, 0.40, 100 minus X, and then 0.3 times 100. This right here, that's your equation. Okay, that's your equation. As we look at that. So just take the first alloy, 0.15X, plus 0.40, 100 minus X, equals 0.3 times 100, which would be 30 grams, okay? Set that up, you're going to solve it, you're going to get X equals 40. X equals 40. Now, you don't have to do the chart. Like if you just say, all right, yeah, that first one's going to be 0.15 times X, and then that's got to be 100 minus X. That final amount's 100. It doesn't matter. But go ahead and solve that. Now, let's see here. Let me just go through it. That's going to be plus 40 minus 0.40X equals 30. 0.15 minus 0.4 is negative 0.25 plus 40 equals 30. Subtract 40. Shoot. Negative 0.25X equals negative 10 divided by negative 0.25, and then 40. Okay, so for that one. Definitely need to know how to do those. Okay, as I said earlier. All right, we are going, any major questions on the homework? What I looked at looked good, but I'm not going to assume I didn't look at every single one. But anything that just sticks out. You had all odd ones, and you've been able to check and see if your answers made sense. Okay. All right, we got one more section to cover. I do have guided notes for you. So let me hand those out. All right, you're going to need to make sure you get a pen. Can't let you use that.
I got one, it's just, they died. Yeah, no, I understand.
That won't
Sorry. It's all on my back, the last building.
Right here.
This piece is gonna cross that, right? 'Cause it's
Right, where they overlap. Okay. So that would be the whole line, and then that one,
that makes sense, that makes sense.
over that. Alright? Alright, me too.
Thank you. No, I do not.
Alright, what I want you to do, there's this first 6 at the top. I just want you to do those on your own. There's a number line underneath there. Did you want to use that as a,
Yeah.
if you want to use that as a, kind of a guide, but like for those 6, write your answer in interval notation. So this is all the possible combinations that can happen. I just want to make sure we're okay with how to write the answers and how to interpret those. So just do those now if you would. Graph it out. Graph it out. All right, the first one is you take a look there. Oh, Thomas, what do you got?
No solution.
What'd you say?
No solution.
No solution. Wait, is this?
Oh, for the first, yeah.
There we go, no solution. Hey, now I got the first two, share the same graph. The only thing that's changed is the word. First one's and. Where do they overlap? They don't overlap, so you gotta put no solution for that one. Tessa, what do you think for the second one?
I have negative infinity to 4, and then 2, and then infinity.
That.
Yeah.
Yeah, that. Negative infinity to negative 4, bracket, union 2 to infinity. Okay, so it's an or. It means we have to include every answer from both parts. They don't overlap, so you have to take each piece individually. That's the only way to write it. All right, Tyson, how about the third one?
Negative infinity, comma 4.
Negative infinity, comma to negative 4, because it's where they overlap. They're going to overlap to negative 4. Okay, agreed on that one. Maggie Schaefer, how about the fourth one?
Negative infinity to 2.
Is where they, you have to take all answers in consideration, negative infinity to 2. Good. 5 and 6 share the same graph. They're going opposite directions, but there is an overlap for that one. Jackson, what do you think for the first one? Or 5?
Negative 4 to 2.
Negative 4 to 2. Agree, including negative 4. Put a bracket there, 2 parentheses. And then the last one. Okay. Kate, how about the last one?
I said parentheses, negative infinity to 2, and then another parentheses, union, bracket, negative 4 to infinity.
Okay, easier way to write that. Because if you take a look at it, are we gonna,
Wouldn't it just be negative infinity to infinity?
it would be. Yep. And you do need to write it that way. Do need to write it negative infinity to infinity. Do not do it as those two different, with a union. Okay, you only do that if they don't overlap. Since they both overlap, it's gonna cover everything. All right, those are basically all the little cases that you can have. Make sure you understand the difference between and or, when they go in the same direction, when they're going opposite directions, when there's a piece missing in the middle, just how to label your answers in interval notation. All right, we're gonna move into 1.7. This is the last section of the chapter that we're covering. Equations and inequalities with absolute value. So just going to jog your memory here. You've had these to some extent at some point. Not trying to insult your intelligence, but just trying to get you going here. Absolute value of x equals 4. 4 obviously works, but what else works? Negative 4. Remember, you're going to get 2 answers for these. So you can say x equals plus or minus 4. All right, second one. Absolute value of x equals negative 7. Can that happen? No, because the absolute value is always going to be what? It's going to be positive, no solution. Okay? So you can either put empty set, you can write no solution for that one. All right, now this one has a little bit of more substance to it. You have the absolute value of an expression equals 25. Now, there will be 2 cases. Here's what you need to do for this. We're going to break it up, like I said, into two situations. The first one is you just drop the absolute value bars. You get 2x plus 5 equals 25. The second one is you want to set it equal to the negative of the number. So if it equals 25, set this equal to negative 25. So that's how you got to get those 2 cases. All right, solve them independently because it's not going to be like plus or minus the same number. So subtract 5. I get 2x equals 20. Divide by 2. I get x equals 10. Now this one's a pretty quick check. Just plug it in. 2 times 10 is 20 plus 5. Yep, that's 25. And then the next, now here's, sometimes people assume, oh, the first answer is 10, next answer is negative 10. Don't assume that. You got to solve it. Because when I subtract 5, I get 2x equals negative 30. Divide by 2, negative 15. Now test that one. 2 times negative 15 is negative 30. Add 5, you get negative 25. Well, the absolute value of that is positive 25. So my two answers are negative 15, 10. Okay. So if its absolute value equals a number, break it up into the two cases. All right, you might have to, I didn't leave you probably as much room, might write small here for this one. Before you break it apart and set it equal to 39 and then negative 39, that won't work. You have to do something first. You have to isolate this absolute value first. So do that. So I'm gonna put that over here. So isolate the absolute value first. And what does that give me? So subtract 7. 4 times the absolute value of 3x minus 8 equals 38. And then go ahead and divide by 4. And so I get the absolute value of 3x minus 8 equals 8. Now, once you get to this point, break it into your two cases. Set it equal to positive 8, set it equal to negative 8. So I get 3x minus 8 equals 8. 3x minus 8 equals negative 8. So one of them's going to be a fraction. Just leave it as a fraction. You don't need to write it as a decimal. Good?
Yeah.
I'll get that. All right, what do I get when I add 8? I get 16. Divide by 3, 16 thirds, and then add 8, you get 0. And then I get x equals 0. These are a pretty quick check. I would always go through that. Go back to the original, because if you made a mistake going to the to where you broke them apart, it would still look like it's right, but it wouldn't check with the original one. But these two work. X equals 0. 16 thirds for that. All right, that fifth one. We're going 2 absolute values, not just one. So we get the absolute value of 2x plus 5 equals the absolute value of 5x plus 4. We still want to use the same idea to break it into two cases. First case, just set them equal to each other. Now, before we always if you had a constant, you set it equal to positive, and then you made it to negative. We want to use the same idea. We want to set it equal to the opposite, the negative of one of the sides. I want to set it to the opposite of the right-hand side. So make this 2x plus 5 equals negative, and then you've got to put it in parentheses, because you got to take the opposite of the whole thing. It's just a constant, you make it negative 25, but here, you got to make it the opposite of the whole thing. All right, solve both of those, check both your answers. you just, that's an absolute value of money, like that. It should just be a 5. Okay, good. What was the first one? You just made careless sound. Double check. All right, Nathan, what do you got for the first one?
3.
3, I agree with that. Subtract 2x. You get 5 equals 3x minus 4. Add 4. 9 equals 3x. X equals 3. When you plug it back in, you get 11. You get 11. So it works for that one. Tessa, how about the second? What would you end up with?
I don't think it's right.
What'd you get?
-0.7.
Well, how come you don't think it's right? Because it's a fraction?
I know, I just don't think.
I think it's right.
Oh,
If you test it, it works. Okay, if you plug it in, it works. -1/7 does work. That is the answer. Make sure you distribute that negative. Make that a +4. If I add 5x, I get 7x. And then subtract 5, 7x equals, -1. -1/7. So I get -1/7, 3. Okay? And they both work. All right, so those are equations. Key thing, be careful. Get the absolute value by itself, then break it up into 2 parts. If you already have the constant there, break it up into 2 parts, you get both answers. All right, inequalities, little different story. Little different story. All right, without me telling you anything, graph all the answers that make that true. Just think about it. I want all the numbers for x if the absolute value of x is less than 2. All the numbers whose absolute value of x is less than 2. All right, describe your solution to me. Okay, tell me how, in using inequalities, what that solution looks like. I don't know if that makes sense here. So just be able to describe it. Dom, any ideas? How would you describe what you have graphed?
X is greater than -2 and less than 2.
You got x is greater than -2. Like this. And x is less than 2. Is that what you said?
Yeah.
All right, so from that means you have this drawn like that, correct? That would be correct graph. Okay, you do not continue it all the way to -infinity because once you get past -2, think about this. -5, what's the absolute value of -5? It is +5, and that is not less than 2. So you have to trap it between it. Now there's another way you can write this, which means the same thing. You can say -2 is less than x is less than 2. Okay, those are equivalent to each other. All right, look at that second one. Absolute value of x is greater than or equal to 2. All right, go ahead, graph what you think the answers will be. Graph what you think the answers will be. Now, let's see. Allie, describe your graph to me using inequalities.
X is less than or equal to 2 and X is greater than or equal to -2.
X is less than or equal to 2. And then what?
X is greater than or equal to -2.
All right, let's see what I graph is what you said. So less than or equal to 2 would be that. Is that what you meant?
Yeah, sure, I don't know.
Is that what you had down?
Yeah.
Okay. Greater than or equal to -2, you had that?
Yeah.
So it hits everything.
Yeah.
All right. It's not going to hit everything. So take a look here because, all right, first of all, think about this. Any positive number bigger than 2 will work. So I want you to slide this one to 2. It needs to be the ones that are always bigger than 2. It's 3, 4, 5. Now, what about for the negative numbers, Esther? What should I have for that one? Any ideas?
You could slide that one over to -2.
I'm going to slide this one over to -2. Now, they don't overlap because now 0 doesn't work because the absolute value of 0 is not bigger than 2. 1 doesn't work. Now, how would you describe this using inequalities? You would say x is less than or equal to -2 or x is greater than or equal to +2. You have to use that word or if you were describing that, okay? All right, now flip it over. Back. We're going to try and create a rule for this. This is always going to be the case if you got less than or equal to. It's going to be trapped between those two values. If it's a greater than or equal to, it's going to be go from to the right from that number and then less than the negative of it. So for here, if a is bigger than 0, a is a positive number there on the right. And u is an algebraic expression. You have 2x plus 5, 3x minus 2. What you can do is you can trap it in between there. So like this. You can write this as -5 is less than or equal to 3x plus 2 is less than or equal to 5. Less than or equal to. Okay, so anytime you have that. And that's basically what we just did here. Okay, hopefully it makes sense to trap just x between the -2 and 2. All right, the second one, it has to be written as 2 separate inequalities with the word or. So if you have 3x plus 2 is greater than 5, you're going to say 3x plus 2 is less than -5, or 3x plus 2 is greater than 5. Okay? Now, a little bit of a device to help you remember. If it is less than, throw a D on there, and you're going to remind you it's an and problem. And if it's a greater, just change the spelling and put OR instead of ER. And so you remember greater. It has to be an or. Less than, it's got to be trapped in between. Greater, it has to be going the opposite way. All right, let's take a look at that problem there. 2x, absolute value of 2x minus 8 is greater than or equal to 16. Now, look at what we just wrote down. And I always like to start with the negative first. We want to know where 2x minus 8, you got to flip the sign as less than or equal to -16. And then 2x minus 8 is greater than or equal to 16. All right, solve those. You do flip the sign on one of them. Okay, when you negate it, you flip that sign. And I should put the word or in there. Or. Okay, because you have to have that. Now, add 8. 2x is less than or equal to -8. Divide by 2. Divide by 2. I got x is less than or equal to -4. Now, what do I get on the other side? Add 8. And I get 2x is greater than or equal to 24. x is greater than or equal to 12, or. All right, that is part of your answer, but I need interval notation. I need it in the simplest form. So if you need to graph it, but I still need your interval notation answer. Now I'm going to graph it just so I have a visual. -4 is here. Less than or equal to means it goes to the left for -4. Here's 12. Close dot to the right. So you're going to write your answer from -infinity to -4 bracket union 12 to infinity. Okay, 12 to infinity. So that's typically how your answer is going to look for one of those orders. We're typically going to go opposite directions for absolute values. You just got to make sure that you are careful there in how you write that answer. All right, let's take a look at this second one. Absolute value of 5x plus 3 is less than or equal to 12. All right, the shortcut for less than or equal to, if you look at what we put at the very top, you can trap it in between the negative and the positive of whatever it's less than or equal to. So take a look at this. I'm going to write this as -12 is less than or equal to 5x plus 3, which is less than or equal to 12. Okay? We're going to trap it in between. Now, if you want to write it as two statements, you got to use the word and. But I think this is easier.
Yes, it gave it this one too.
If you're going to write it as two statements, here's what you're going to do. You're going to say 5x plus 3 is greater than or equal to -12, and 5x plus 3 is less than or equal to +12. Okay? So yeah, you got to negate it and switch that sign. All right, solving this, subtract 3. Subtract 3, and what do I get? I get -15, less than or equal to 5x, less than or equal to 9. Divide by 5, divide by 5. I get -3 is less than or equal to x. I'm just going to leave that as 9/5. Okay, it's 1.8, but you can leave it. And now it's going to be bracket -3, -3 to 9/5. Okay, for that one. All right, I want to make sure we get all the way through here. I'm just going to talk about this next one here. What do you think you got to do first after you get set up? Before you can do anything, you have to get the absolute value alone. All right, let me just set this up. I'm not going to finish that one. So I subtract 3, and I get x over 2 plus 12 is greater than or equal to 8. Now, since it's greater, you're going to get x over 2 plus 12 is less than or equal to -8, or x over 2 plus 12 is greater than or equal to 8. All right, and I'm just going to leave it from there. You guys, we've done a couple of those. So make sure it's or less than or equal to -8. All right, those last two. There's absolutely no work to do if you look at them closely and think about it. So put down greater than or equal to -3, put down less than or equal to -8. There's a negative. Anytime you have an absolute value, whether it's an equation or inequality, and you got a negative, you want to look at it really close before you start doing any work. Now, if I give, does the number 6 work for the first one? If you plug in 6, will it work? 12 minus 5 is 7. Is the absolute value bigger than -3? Yeah. Will -2 work? 2 times -2 is -4, minus 5 is -9. Absolute value of that is 9. It works. What's our answer for this one? What's that? Oh, I thought you said it. All real numbers. Everything will work. Because the absolute value is always going to be what? It's always going to be positive, and it always has to be bigger than a negative number. So it's all real numbers. Negative infinity to infinity. Okay? Well, when will the absolute value be less than a negative number? Never. Absolute value is always positive. It has to be bigger than -8. So this would be no solution. Okay, no solution. So anytime you got a negative, you got to stop and look at it. All right, I'm going to give you actually two things here. The first one, here's your homework. Okay, there's your homework. That's for section 1-7. For anybody, this is the chapter 1 review. This is not homework, but if anybody wants to get a head start for getting ready for the test, that's over here. Okay, we'll do some of it Monday. I'm going to give you some time in class, not the whole class period, but some to go over that. But that's the chapter 1 review. Okay, that's the homework that needs to be done. That's optional at this point. It will be done at some point. And if you want a head start, you can get that. I mean, you can start on it this week. And it'll also be on Canvas. You know, if you open up the notes, it'll be on there as well. The review, optional till Monday. I mean, then it'll be part of an assignment. But if you want to get a head start, that's fine. But this needs to be done here. And